Okay, welcome to the Exam Review B, page 12 through 15 videos. We start with question 29, and the idea here would be how many points of intersection the graphs of the circle x squared plus y squared equals 16 and the parabola y equals x squared have. And we can use the grid to help us, so I'm going to go ahead and graph this circle to start with. So this circle right here should have a radius of 4, and since it's x squared, y squared, it just has a center of 0, 0. So the center is 0, 0, the radius is 4. That was from the square root of 16. So I'm going to do a rough sketch of the circle. I'm going 4 out every direction from the center. I'll just do a quick freehand sketch of the circle. That should be good enough. And then this parabola should be an upward parabola. It should have a vertex of 0, 0. And I think that's the only information I'd really need to be able to solve this. So it has a vertex of 0, 0. It opens upward. So roughly it'll look something like this. And it's pretty obvious now that I have 2 points of intersection, and that will be the answer for number 29. Okay, question 30. So same idea, this time we have 2 different circles. This circle is going to have a radius of 2 because the square root of 4 is 2. The center of this first circle is going to be 2, 0. Since it's x minus 2, that translates to an x value of 2, and then y squared has nothing with it, so that's why the value of 0 is the y coordinate for that circle. So the center is 2, 0, the radius is 2, so I can go up 2, I could go right 2, left 2, down 2, and then a rough sketch of the circle would look like this. Okay, and the second circle is going to have a radius of 2. I get that from the square root of 4. And then the center of that circle is going to be negative 2, 0. Again, the coordinate is positive 2, but it actually changes to a negative 2. And that means the center is here. The radius is 2, up 2, left 2, down 2, right 2. So how many points of intersection do these have? Well, they have 1. They intersect right at this point. So that's the point 0, 0. They don't really ask what the point is, they just say how many points does it have, so it has 1 point of intersection. And that just happens to be at the origin, 0, 0. Okay, here comes 31. Okay, so this has several parts to it. We start by looking at this line, line AB, and we have to find the length of segment AB. This is just a distance formula question. On your formula sheet, you'd be able to find the distance formula, and we can plug right in. I could call this x1 and y1, and I could call the other 2 points x2 and y2. Sometimes that helps you get the formula set up, just to define which one's the first point, which one's the second point. From here, I'm just plugging right into my distance formula. So I can do x2 minus x1 squared. That will be negative 10 minus 10 squared, plus y2 minus y1 squared, so negative 7 minus 8 squared. And I'm just simplifying. Negative 10 minus 10 is negative 20, so negative 20 squared. And then negative 7 minus negative 8 is negative 15 squared. So if I square both of them, add them together, that ends up being 400 plus 225. 400 plus 225 is 625, and we get lucky because the square root of 625 is 25, and that's going to be the answer for number 31. So that's 25 units, the distance from A to B. Question 32. Point C is between points A and B and has the coordinates 2, 2. What is the ratio AC to CB? I'm going to go back and get a blank screen for this so I can start from scratch. So 2, 2 is point C. 2, 2 is point C. I need the ratio of AC to CB. What I can do is just find how far left it is from B to C and how far down it is from B to C. So I'm counting this vertical and this horizontal distance. The horizontal distance is 1, 2, 3, 4, 5, 6, 7, 8. And the vertical distance is 1, 2, 3, 4, 5, 6. I'm going to do the same type of thing from A to C. So I'm counting how far up it is from A to C, and then how far right it would be from A to C. So it's up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I can really just compare the ratio between my red vertical and horizontal lines and my blue vertical and horizontal lines. So I can compare 8 to 12 or 12 to 8, and then I can compare the 9 and the 6 together. Now the question says AC to CB, and AC is listed first, so I should put that number on the top of my fraction and then the CB number on the bottom of my fraction. So AC to CB. So AC would be either this 9 or this 12. Those come from AC. So I could put 9 on top, and then 9 is a vertical distance, so it matches with 6, this vertical distance from BC. So 9 to 6. That will be the same as doing 12 to 8. Both of these fractions reduce. 9 over 6 becomes 3 to 2, or 12 over 8 becomes 3 to 2. And that's the answer for number 32. It's just a 3 to 2 ratio. All right, and number 33. For 33, I'm going to go back to a blank screen again. So this time, I have to find the coordinates of point D so that the ratio of AD to DB is 1 to 4. So when they ask you for a ratio of 1 to 4, you actually need 5 parts. So I'm doing 1 plus 4 to get 5. If I can break up the segment into 5 equal parts, then it would be easy to find a 1 to 4 ratio, 1 being the small part, and then of course there's 4 left over to make a 1 to 4 ratio. So I'm going back to my main diagram, and I'm just going to make one big right triangle out of this. So I'm going to go straight over all the way to the end and then straight down. And I'm going to count the distance horizontally and vertically, kind of like I did for question 32. So counting horizontally across the top, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's 20 across the top. And if I didn't want to actually count that out, I could have found that without counting it, because it starts at 10, that's an x value, and it goes to negative 10. So the distance from 10 to negative 10 is 20, or we can say the difference from 10 to negative 10 is 20. So I didn't really have to count that one by one. I could have found it a little bit faster. To do my vertical distance, I could count it one by one, or I can realize that I'm starting at negative 7, I'm going up to positive 8. From negative 7 to 8 is a difference of 15. So I know it's going to be 15, but just to make sure, I'm going to count individually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 15. All right, now I'm going to use that 5 number that I came up with. I need 5 equal parts. So I'm going to take 20 and divide that by 5. 20 divided by 5 is 4. And that's telling me to take this horizontal side here and divide it by 4s. Divide it every 4 units, basically. So I'm starting over here at point B, and I'm going to go 4 and then make a little slash. So 1, 2, 3, 4 slash. 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 And 1, 2, 3, 4 slash. So now I have 5 equal divisions. 1, 2, 3, 4, 5. Let me do the same thing for the vertical side, the 15 side. I need to do 15 divided by 5. That gives me 3. So I'm going to make a mark at every 3 units. So 1, 2, 3, mark. 1, 2, 3, mark. 1, 2, 3, mark. 1, 2, 3, mark. And then 1, 2, 3, I'm at the end. So at each of these red marks and at each of these blue marks on the top, I can just make those marks a little bit longer. So like this blue mark could actually go all the way down. Whoops. Do that again. So the blue mark goes all the way down. My red marks, the same thing. I can make them all the way over until they hit the line. And what that's doing is it's really cutting up my original AB segment into 5 equal parts. So these points I'm making are separating AB into 5 equal parts. Now the question was saying I need point D to be in the place so that AD to DB is 1 to 4. That means that AD is going to be the smaller part. And that means that DB is going to be the larger part. So the order that they write the ratio is important. Since it's a 1 to 4 ratio, 1 is for AD and 4 is for DB. So these red points that I made, any of them might end up being D, but you have to make sure you put D in the right place. So again, AD is the 1 part and DB is the 4 part. So if I put D here, that's going to do the trick, because now I have 1 part, so AD is 1, and then the rest of this segment, which I'm highlighting in yellow, DB is the 4 part. So point D, after all that work, we can get the answer. Point D is at -6, -4. And that finishes up question 33. Okay, question 34. We have a given line. The equation of that line is 3x minus 2. And in letter A, we have to find a parallel line to line K, and it passes through point 0,2. First thing we can review here is that this is y equals mx plus b form, where m stands for the slope, and b stands for the y-intercept. So the slope is 3 for the given line, and the y-intercept is -2 for the given line. We can see the y-intercept here, and the slope is 3, meaning you could go up 3, 1, 2, 3, and over 1, up 3, and over 1. So that's really what this equation means in the way it's given to you in the beginning. So keep all that in mind. Then we can actually go on and look at question A again. I need to make a parallel line, parallel to K, passing through the point 0,2. When it says passing through the point 0,2, the point 0,2 would end up being the y-intercept of my new line. So the b value is going to be 2 in my new line. 0,2 is right here. So wherever my new line is, it's going to pass through that point 0,2. Now the slope of my new line, so the m part of my new line, should be 3 also, because if the original slope was 3 for line K, that means my new slope has to be 3 because parallel lines have the same slope. And this is the key fact that's going to be used in a couple places, probably on your final exam. So parallel lines have equal slopes. So I know that my b is going to be 2, and I know my m is going to be 3. I can put that all together and answer the question, and we can say the equation of the line is y equals 3x plus 2. I don't have to actually graph the line. The direction just said to write the equation. So this is it for letter A, y equals 3x plus 2. Okay, letter B is a similar question, but now I'm doing a perpendicular line, and it passes through a different point, -5. This 0, -5 is another good point, because that is going to be a y-intercept. Anytime the x value is 0 with a point, that means it's on the y-axis, so it's a y-intercept point. So the y-intercept is going to be -5. The m value is not going to be 3 again. In letter A, it was just 3, because parallel lines have the same slope, but for perpendicular lines, it's a different rule. We say that perpendicular lines have opposite reciprocal slopes. Your teacher might have called that negative reciprocals. Negative reciprocals or opposite reciprocals really mean the same thing, and that means that the two slopes are reciprocals of each other, so they're flipped upside down, and they're opposites of each other, opposites in terms of their sign. So if one slope, just for an example, if one slope was 2/3 and the other slope was -3/2, those are considered opposite reciprocals. Opposites because the first one's positive and the second one's negative, and they're reciprocals because they are flipped upside down. So in the current question, the original slope was 3, as was given in the original directions. So my new slope is going to be 3 flipped upside down and 3 made into negative. So that would make it a -1/3 if I flip it upside down and make it negative. So put it all together, and the answer is going to be y equals -1/3 x minus 5. So that's the answer for letter B of question 34. Okay, page 15. So the questions on this page all use this diagram. And we'll have to use maybe the slope formula, maybe the distance formula, maybe the midpoint formula. Throughout this whole section, we have to refer back to those formulas and know when to use them and how to use them. Remember that the formulas are given on the formula sheet, so there's no need to memorize the formulas. Again, just know how to use them and when to use them. All right, Kelly thinks this figure might be a square. In order to prove that something is a square, there are a lot of steps you have to go through. So it's kind of a long process here for Kelly to prove her point. And this walks us through step by step basically how we would go about proving that something's a square. So she remembers from her geometry class that she's supposed to do the following. First, she needs to know if it's a parallelogram, because if it's not a parallelogram, there's no way it could be a square. If it is a square, first step, find that it's a parallelogram. So this question says to show that it's a parallelogram by showing that the slopes of opposite sides are equal. Question 35, they made it kind of an easy question because they told you what to do. They said how to show it. On the actual exam, they might not be that nice to you. So you should know to show that something's a parallelogram, you need to do slopes and show that opposite sides have equal slopes. So the slope formula is y2 minus y1 divided by x2 minus x1. So I'm going to do that for all 4 sides, starting with AB. So AB, I'm going to do 5 minus 1. And if I do 5 minus 1, I should also do 1 minus 4 on the bottom. The order is important. As soon as I do 5 minus 1 and 5 is my first point, that means that 1 has to come next in my denominator. So when I simplify this, 5 minus 1 is 4. 1 minus 4 is -3. A positive divided by negative is really just a negative. So I'm going to rewrite that as -4/3. And that is the slope of AB. All right, let me do CD next, because I think that CD is going to have the same slope answer, because AB and CD look like they're the 2 parallel sides. Those opposite sides should be parallel. So CD is going to come next for my work. So CD, let me do actually, when I started to do CD, I noticed I made a little mistake, but at least I caught the mistake now, not later. For AB, I made a mistake because I did 5 minus 1 on top and 1 minus 4 on the bottom. The y should go on top and the x's should go on the bottom, just like I wrote over here in the formula. So I actually need to go back and fix that. Really, just to fix it, I have to flip my final answer upside down so that the y goes on top, the x goes on the bottom. But just to be certain about this, let me go back and fix it all together so I don't confuse anybody. When we make these videos, we can't go back and edit a portion, so I have to just go with it if I make a mistake. Hopefully this is my only mistake. Alright, so I'm going back to AB, and I need to do the y's first. So 1 minus 4 should go on top, y2 minus y1, and now 5 minus 1 should go on the bottom. So that's -3/4. Alright, so AB is fixed. Let me do CD next. Again, I think that CD is going to have the same answer. So for CD, I'm going to do -3 minus 0. That's just -3. And now 2 minus -2. To be careful of my signs, 2 minus -2. That's going to be a -3 on top and a 4 on the bottom. So that's the slope of CD, negative 3/4, and then AB is also negative 3/4. So those slopes are equal to each other. All right, I need to do BC. Let me do that slope next. So BC. So for BC, let me do negative 3 minus 1 on top, and then 2 minus 5 on the bottom. That ends up being negative 4 and negative 3. A negative divided by negative is a positive, so that's positive 4/3. All right, and my final side that I have not done yet is AD. So for AD, I'll do 4 minus 0. So that's just going to be a 4. And then 1 minus negative 2. Again, being careful with my signs, that's a double negative down there. So 4 and 3, and that will be it. So I think this would be enough to get credit. I've shown that AB and CD have equal slopes. So those were opposite sides. And I've shown that BC and AD have opposites. Their slopes are the same as well. So that will be the end of 35. Okay, 36. Now Kelly wants to show that it's a rectangle, because if she's going to show that it's a square, and that's her main goal, she has to show that it's also a rectangle. A rectangle has to have 4 right angles, and there's 2 ways to do that. So in 36A, it wants her to use slopes. And we can show that one of the angles is a right angle, in which case all the angles would be right angles, and the figure would thus be a rectangle. So to show that an angle is a right angle, I can use the idea of slopes, and I'm looking for opposite reciprocal slopes. Just like we did on the last page question, we were trying to find that line that was perpendicular to K. We use the same idea here. Now the good news about this is I already have slopes worked out. In number 35, I did the slopes of AB, CD, BC, and AD. So I can just refer back to that work and answer question 36A. So in question 36A, I knew that AB had a slope of negative 3/4. And in question 35A, or in question 35, I knew that BC had a slope of 4/3. I just have to notice that negative 3/4 and positive 4/3 are opposite reciprocals. I can just put that into a quick sentence. And since they are opposite reciprocals, that means that they'd be making a right angle with each other. So actually letter B, point B, that's where the right angle would be located. So since AB and BC are opposite reciprocals, that means they are perpendicular. Angle B must be a right angle. On the exam, there's going to be a lot of questions that ask you to justify your answer and actually write out your thought process. So get in the habit of actually writing out a sentence or two to explain what you really mean, just to be safe. If I only write this, I'm not sure I'm going to get full credit because I didn't really explain my thought process. So I really needed this sentence to make it clear what I was doing and how I solved the question. All right, letter B. And this will be my last question of the video, of this part of the video. So we need to show that the diagonals of the parallelogram are congruent. This is another way to show that something's a rectangle if it has congruent diagonals. So if I go back to my original diagram, the diagonals are B to D. That's one diagonal. And the other diagonal is A to C. So if those are the same length, then it must be a rectangle. So I need to do the distance formula. Distance for AC and the distance for BD. All right, let me do the distance. Let me write out the distance formula first. And again, this would be on your formula sheet. So x2 minus x1, or it could be x1 minus x2, it doesn't really matter, plus y2 minus y1 squared. The whole thing is square rooted. So let me do that for AC first. So I'm seeing how long AC is. All right, A to C. I'm going to do 4 minus negative 3. So that's x2 minus x1. And then I'm going to do 1 minus 2 squared. Start to simplify. 4 minus negative 3 is 7 squared. 1 minus negative 2 is negative 1 squared. And if I keep going, 7 squared is 49. Negative 1 squared is 1. So this turns out to be the square root of 50. The square root of 50 could be rewritten as a decimal. If I wanted to put that in the calculator, it's going to be 7 point something. But I don't really care about what it simplifies into. What I do care about is BD the same? That's the whole point of the question. Is BD going to also be the square root of 50? Or is BD going to be something different? So the distance formula for BD, I would do 1 minus 0 as my x2 minus x1 part. And then 5 minus negative 2. And it's going to turn out to be 1 squared and 7 squared. So I think it is going to be the same as the above work. It's still going to be 1 and 49. So that is the square root of 50, just like AC was the square root of 50. And I think that will be it for number 36B. And I am finished. So enjoy pages 12 to 15.